Okay, this is problem number 3 on the 10.3 homework. It says the mean waiting time at a drive-through of fast food restaurant from the time an order is placed to the time the order is received is 87.9 seconds. And a manager devises a new drive-through system that believes he will decrease the wait time. So decrease the wait time, that's going to be our clue as to what kind of hypothesis testing we do, whether that's a left-tailed, right-tailed, or two-tailed test. As a test, he initiates the new system and measures the wait time for 10 randomly selected orders. So far we know that our mean wait time is 87.9, that's our mu, and our n, our sample size is 10. And the wait times are provided in the table at right. So in part A, it says because the sample size is small, then we can't just go ahead and assume normality by the central limit theorem. Instead, we have to go graph the probability plot, a normal probability plot, which fortunately they did for us. Go find the correlation coefficient, which again they did for us, luckily. And we're going to compare that correlation coefficient against the critical value. So they gave me this number in the problem. I have to go down, and in MathXL, they gave us the critical values chart. And so we go to sample size 10, and it's 0.918. So comparing 0.983, that's the number they gave us in the problem here, to the critical value 0.918, the question is the correlation coefficient greater than the critical value? And if so, plot is normal. Your distribution, let's call it a distribution instead of a plot. Your distribution is normal. Okay, so now that we know that, so we can say yes, the conditions are satisfied. The normal probability plot is linear enough, and this little test right here is how we know if it is linear enough. Question mark. Okay, so this is our little test for is it linear enough, since the correlation coefficient is greater than the critical value, and that's what we saw here and here. In addition, a box plot does not show any outliers. So I can't remember if I showed you guys how to do a box plot in the graphing calculator. I know we did one by hand, but let's go look real quick on how the graphing calculator can do this for us real quickly to check for outliers. So I went to stat and number 1 edit, and I've already entered that data from the problem up here, this stuff. I entered in my L1. So there it is. And so then I went to, you see up here it says in blue, stat plot above y equals. So I went to second and y equals. And you got to make sure this plot 1 is turned on. So I'm going to just go ahead and click on that plot 1. And I've turned it on by highlighting on and typing enter. And then I went over here to choose box plot, which for me is the 1, 2, 3, 4, 5th option. And then if you hit zoom and number 9, you see how number 9 says zoom stats? It'll automatically set your window appropriate to something for what's in your L1. And so there you go, and you can see it did not graph any points outside of our box plot. Our whiskers encompass all the points. All right, so let's go on to part B. Is the new system effective? Conduct a hypothesis test using the p-value approach and a significance level of 0.1. So we know that our mu naught will equal 87.9, and it'll be less than. And in case you forgot, it was less than because he wanted to know if he could get that wait time down, that mean wait time to be less than 87.9. All right, so we go back to our calculator for this next piece, and I'm going to show you how I got this t-test screen right here. So, whoa, go away. So to do that, you're going to go to stat Again, make sure that you have entered that data from the table in the problem in your L1. So if you have not already done that, that is this data up here that you're entering in your L1. So I did that, and then I went to Stat. I went over to the third option, Test, and it's a number 2. A t-test is what we use for testing the mean instead of testing the proportion. So now I've chosen data instead of stats because they gave me that table of data, and I've entered my mu naught to be 87.9 because that was the mean wait time before we did this little test. And I've got my left tail test, it's less than mu naught. And so then we go down here and hit calculate, and there's my number. So I've already copied and pasted a picture of my screen here on the problem. All right, so it says find the t-statistic, round to 2 decimal places as needed. So this is the t-test statistic right there. And so to 2 decimal places, that would be negative 2.03. And then find the p-value, that's this guy here. This one's to 3 decimal places, so 0.036 would be sufficient for 3 decimal places. All right, then use the alpha at the 0.1 level of significance. What can be concluded from the hypothesis test? All right, so we know that we compare our p-value to the alpha, and if p-value is less than alpha, we reject H naught. We reject the null. So in this case, our p-value is 0.036, and our alpha value was, where did it go? Okay, so our alpha was at the 0.1 level. So since p-value is less than alpha, we do reject H naught. So we would say not this one, p-value is not greater than, so it's less than, let's see the difference here. So not sufficient, and this one is sufficient. So our answer is D. Remember, if you do not reject H naught, then you should have this word not in your answer. All right, so our answer is D, and I think that's the end of this problem.